All right, defining modules, control scope, and privacy. Let's see. It's a bunch of reading. Talk about modules and other parts of the module system, namely paths, that allow you to name items, the use keyword that brings a path into scope, and the pub keyword to make items public. We'll also discuss the as keyword, external packages, and the glob operator. First, we're going to start with a list of rules for easy reference when you're organizing your code in the future. Then we'll explain each of the rules in detail. Alright, cheat sheet, huh? Cool. Here we provide a quick reference on how modules, paths, and the use keyword and the pub keyword work in the compiler and how most developers organize their code. We'll be going through examples of each of these rules throughout this chapter, but this is a great place to refer to as a reminder of how modules work. Start from the crate root. When compiling a crate, the compiler first looks in the crate root file, usually librs for library crate or main.rs for a binary crate. In this case, I have a main.rs here. Declaring modules. In the crate root file, you can declare new modules. Say you declare a garden module with the mod garden. Okay, the compiler will look for the module's code in these places, inline within curly brackets that replace the semicolon following mod garden. Oh, interesting. So you can do something like delete these, mod garden, and then put a block. Define the module. In the file garden.rs, or a folder and then mod.rs file. Interesting stuff. So I could have a md garden. Right. It's right there. And then let's make a garden new file. I could do mod.rs, and this would be my module. Could do, can I do print line directly here? Hello, welcome to my kernel. Mod garden, and I could do this. Couldn't I? Can't find module, garden rs or garden mod rs. Why? It's right there. It's under garden. Oh, it needs to be under source, of course. Right. Now it's there. Under source garden. So not garden itself. So get into source and then contents. We have garden there. That's garden. Inside garden we got mod. Okay. Sure, that makes sense. And if I run this, I should get, could not compile. Really? Why not? Not compile Raspberry due to previous error. Macro expansion ignores token and any following. Well, how do you get stuff in here? What about this? Can I do that? No. Non-inline module inside a block unless it has a path attribute. Don't have a path attribute. Okay, let's not get ahead of ourselves here. Declaring submodules. In any file, close the terminal as well. How do I get rid of this terminal? In any file other than the crate root, you can declare submodules. For example, you might declare mod vegetables in source garden rs. Compiler will look for the submodule's code within the directory name for the parent module in these places. Inline, so the same thing with curly brackets. Inside vegetables.rs under garden, or you'll have another folder, vegetables, and mod.rs. Paths to code in modules. Once a module is part of your crate, you can refer to code in that module from anywhere else in that same crate. As long as the privacy rules allow, using the path to the code. For example, an asparagus type in the garden vegetables module would be found at crate garden vegetables asparagus. You say crate like this? Interesting. Private versus public. Is our crate called crate? Maybe this is the name of the crate. Private versus public. Code within the module is private from its parent modules by default. To make a module public, declare it with the pub mod instead of mod. Okay, to make items within the public module public as well, use pub for their declarations. The use keyword. Within the scope, the use keyword creates shortcuts to items to reduce repetition of long paths. In any scope that can refer to crate garden vegetables asparagus, you can create a shortcut with use. Use crate garden vegetables asparagus, and from then on you would only need to write asparagus. Make use of that type in the scope. Here we create a binary crate named backyard that illustrates these rules. The crates directory, also named backyard, contains these files and directories. Backyard, garden, vegetables. Let's do that. So cargo, new backyard. And then inside the source, cd source, you have garden, md garden. And you have garden rs and main rs. Let's get out of Rustbook here and get into backyard. Forget this. Okay, so this is main for backyard, and inside garden we need vegetables.rs, and then in src we also have a garden dot. Okay. The crate root file in this case is main.rs, and it contains function main. Use crate garden vegetables asparagus, and then pubmod garden let plant the asparagus, whatever that is. I'm growing debug stuff. Exclamation mark again. Fine. The pubmod garden line tells the compiler to include code it finds in source garden RS, which is pubmod vegetables. Here, pubmod vegetables means code in source garden vegetables is included too. That code is derive debug obstruct asparagus. It's a struct with no data. Okay, let me run this. Argo run. I'm growing asparagus. And we got it working. So crate, this is a special keyword then, and you have to have it here. Garden, vegetables, asparagus. And you include garden RS code by typing in pubmod garden, which contains pubmod vegetables. So includes vegetables submodule. And inside vegetables submodule, you have a public struct asparagus. But if you didn't have a public struct, let's say you have a, let's get it, another struct here, drive debug and make it not public. Struct, for example, tomato. Can I actually refer to that? Tomato. It's not public. Right. Not found in the scope. So it's not, if it's not public, you cannot use it. Unused import. Struct blah exists, but is inaccessible, right? So to make it accessible, you need to have this pub keyword here. Then it will be able to, no, not compile. Okay. It's pub now. Try again. Why not? Consider importing this struct. Use crate garden. Oh, I didn't import it. That's why. Model. You need to actually import that as well. Then let's do this again without the pub keyword. See what will happen. If I go run. Okay. The struct model is defined here. Private struct. Okay, that's a better better feedback now. Okay, so let's do pub. Now run, and no complaints. Okay. Grouping related code in modules. Modules let us organize code within a crate for readability and easy reuse. Modules also allow us to control the privacy of items because code within a module is private by default. Yeah, so to make this struct accessible from other files, you have to have the pub keyword here. Private items are internal implementation details not available for outside use. we can choose to make modules and the items within them public, which exposes them to allow external code to use and depend on them. As an example, let's write a library crate that provides the functionality of a restaurant. We'll define the signatures of functions, but leave their bodies empty to concentrate on the organization of the code rather than the implementation of a restaurant. In the restaurant industry, some parts of a restaurant are referred to as front of house and others as back of house. Front of house is where customers are. This encompasses where the host seat customers, servers take orders and payment, and bartenders make drinks. Back of house is where the chefs and cooks work in the kitchen, dishwashers clean up, and managers do administrative work. To structure our crate in this way, we can organize its functions into nested modules. Create a new library named restaurant by running cargo new restaurant lib. Oh. Okay, let's do that. Go back to Rust here. Cargo new restaurant, which is a library. Okay, and then enter the code in listing 7-1 into source librs to define some modules and function signatures. Okay, let's open that up in VS Code. Let's go to restaurant, source, librs. And close other files. Close others. There we go. Oh, look at that. There's a bunch of boilerplate code. To define some modules and function signatures. Here's the front house section. Okay, I'm just going to type that in. Mod front of house. So this is a module, but it's not in a separate file. It's a module in the same file, right? And then inside this module, there's a submodule called hosting. And it has some functions. Add to wait list. We're not defining functions, of course. And then function seat a table. And then there is another submodule called serving inside the front of house mod. Which has take order as a function. Implementation details we don't care about. Serve order. And then take payment. Okay. We define a module with the mod keyword followed by the name of the module, in this case front of house. The body of the module then goes inside curly brackets. So this entire code is the body of front of house module. Inside modules, we can place other modules, as in this case with the modules hosting and serving. So these are sub-modules of the front of house module. Modules can also hold definitions for other items, such as structs, enums, constants, traits, and, as in listing 7-1, functions. By using modules, we can group related definitions together and name why they're related. Programmers using this code can navigate the code based on the groups rather than having to read through all the definitions, making it easier to find the definitions relevant to them. Programmers adding new functionality to this code would know where to place the code to keep the program organized. Earlier we mentioned that source main.rs and source lib.rs are called crate roots. The reason for their name is that the contents of either of these two files form a module named crate at the root of the crates module structure, known as the module tree. So that's the module tree. And crate is, I guess, the root. This tree shows how some of the modules nest inside one another. For example, hosting nests inside front of house. The tree also shows that some modules are siblings to each other, meaning they're defined in the same module. Hosting and serving are siblings. So hosting and serving are sibling modules. They are at the same level, right? They're not a sub or parent module of each other. They're at the same level. They're both child modules of front of house. If a module A is contained inside module B, we say that module A is the child of module B, and that module B is the parent of module A. Notice that the entire module tree is rooted under the implicit module named crate. The module tree might remind you of the file system's directory tree on your computer. This is a very apt comparison. Just like directories in a file system use modules to organize your code, and just like files in a directory, we need a way to find our modules. All right. So next up we have paths, and we'll talk about that in the next video.